The first part of today's preparation is about break-even analysis. So, break-even analysis is when you determine when the value of one alternative becomes equivalent to that of another. So it's not that we have two alternatives with everything being the same or fixed values. We need to, there's some variable, whether it's time or number of units produced within a certain amount of time. Something is variable in the alternatives, and we need to figure out what value of that variable do the two alternatives become equivalent. So let's do it by example. So you might have a break-even quantity, the number of units that need to be manufactured to make a profit. You can imagine it takes a lot of money to set up a manufacturing business. So you have to buy machines, etc. At what point, how many units do you have to produce does it take to actually start to break even? Right? The colloquial meaning of break even meaning you have as much money as you started with is one example. So here's an example. Two plans are available for a company to obtain automobiles for its sales staff. They can rent the cars and they'll pay 15 cents per mile, or they can purchase the cars for a ridiculously low amount, $5,000. Maybe they're getting a large discount because of the quantity they're purchasing them in. Each car has an economic life of only 3 years. After that, they're going to salvage them for $1,200 each. Insurance is going to cost $500 per year. That's flat. Doesn't matter how far they drive, apparently. But gas costs 4 cents per mile. So it's a lot less than the rental cost per mile. So you can imagine at some point you're going to drive enough miles that the savings due to gas costs are going to offset all of these additional upfront costs and yearly costs, annual costs. So how much do they have to drive per year in order to make these two options equivalent? Assuming 10% interest rate, how many miles must the cars be driven annually for the two plans to be equivalent? Let's solve that problem. So here's the details of the problem, and it says how many miles needed the cars be driven annually for the two plans to be equivalent. So let's use the variable x to mean the number of miles driven per year. And that is going to factor into our problem. So here's one, and how are we going to approach this? Let's start out with net present value. So option A, we're going to pay 15 cents per mile. So we have x is the number of miles per year. We've got 3 years times the number of miles per year multiplied by 15 cents, right? And you'd think, oh, that's the total amount of dollars that would have to be spent, right? $0.15 per mile times that many miles per year times 3 years, that's the total number of dollars spent. But we want to calculate the net present value of that, so we can't just multiply everything together like that. We have to figure out, okay, it's this many miles per year multiplied by 15 cents per mile, but then we're going to actually have to multiply by a discount factor that gets the present value from that annuity, given that annuity, at an I% interest rate. We've got a 10% interest rate in this problem, and n equals 3 years. So instead of just multiplying by 3, we need to multiply by this discount factor. So the net present value of this option, that. Let's look at the net present value of B. Well, initial purchase cost, $5,000, plus salvage value, so this is actually a negative amount. Maybe this should be negative as well, because this is a cost. Negative 5,000, plus we've got a salvage value of 1,200, but that 1,200 we're going to have to bring back to the present time. So a P over F factor, 10%, 3 years. We've got insurance, that's an annuity, $500 per year, so we have to subtract 500 and multiply by the P over A, 10%, and 4 cents per mile per year. So we're going to have the same sort of thing. We're going to have 0.04 times x, and then multiply by the discount factor. It's the same sort of idea as this one here. It's an annual cost that depends on the number of miles you drive in a year. So you multiply the cost per mile times the number of miles per year times the discount factor that converts that annuity into a present cost. So we'll get the P over A from that. Let's look up these factors. Okay, so here's our discount factor table for I is equal to 10%. We need the P over A, 10%, n equals 3. So P over A, 10% for n equals 3. 2.4869, a little less than 3. Same thing here. Okay, we need same discount factor here. So the only other one you need is the P over F, 10%, 3. P over F, this is the 10%, 3 years, 0.7513. Okay, and then we need to figure out what number of miles per year do these two things become equivalent. This was a 3-year plan for net present value. This was another 3-year plan. How many miles per year X does it take to make these two things equal? So we'll set the two equal to one another. NPV of A is equal to the NPV of B. So let's do a little bit of algebra. I'll speed this part up. So we can multiply both sides by -1, and we'll subtract, oh, this is multiplied by x. Let's subtract this from both sides. And we'll divide both sides by this factor. Okay, so if we drive at least 19,527 miles per year, then these two options are equivalent. And we can kind of intuitively see that below that, well, this is going to be much more expensive, right? If you drive 0 miles per year, then the net present value of option B is still going to be, some 5,000, plus you're going to pay insurance every year. This is going to be expensive, whereas you drive 0 miles per year, you don't pay anything. But if you drive more than this, well, if you drive exactly this, then the two become equal, and if you drive more than that per year per car, then it starts making sense to have purchased the cars outright.